All right, good morning, everyone. Well, thanks for joining the How Power Works at UCR presentation. We're going to be reviewing our campus electrical infrastructure. And so I'll do some brief introductions and overview of the presentation in the coming slides. So next slide. So before we get started, just a little bit about the format of the presentation. We'll be taking comments and questions via the chat box and the Q&A box as well. And we'll address these questions or comments at the end of the presentation just to keep it flowing. And as I mentioned, the presentation will be recorded. Next slide. So just a quick overview of the agenda. We'll be doing an introduction overview of facilities and energy and engineering, going over the power distribution network and UCR infrastructure. Also reviewing power disruptions and power outages here on campus and, things to consider. Our electrical distribution projects that facilities and PDNC have undertaken within the last few years, and some future electrical substation maintenance that we're planning for next year. So next slide. All right, guys. Well, my name is David Palacios, and I'm the Director of Energy and Engineering and Campus Energy Manager. And on the right side, you can see my energy team, Chad Cisco, Energy Engineer, and Alejandro Gonzalez, Associate Energy Engineer. So they both have mechanical engineering backgrounds, and myself have an electrical engineering background with an emphasis in power systems, licensed electrical engineer with the state of California, and also certified energy manager. Also with us on the panel is our Associate Vice Chancellor of Facility Services, Adam Schnurl. So he'll also help answer any questions that you guys may have at the end of the presentation. And if you guys ever have any questions or comments or any ideas or just want to get in touch with the energy team, our information is down below. You can visit us at our website at energy.ucr.edu and also our department email at energy@ucr.edu. So just in short, our mission for energy and engineering is to create a smart, resilient, energy efficient, and sustainable campus. So this includes, touching a lot of the parts of the infrastructure within UCR. So next slide. And so what is the purpose of, this presentation, how power works in general? It's really to educate, the greater campus community, and it's really for anyone that's interested, but in particular, we're really focusing on some of the schools and colleges of the university and building stakeholders. And why is this important? As you guys may or may not know, the electrical grid is, very important within the UC Riverside campus, and outages and disruptions have occurred in the past, and they have also not occurred in the past, right? Which is a good sign, but as our weather becomes more extreme and as we continue to grow as a campus, we really need to make sure that we do understand at a fundamental level our electrical infrastructure and a lot of considerations regarding it. So what is UCR really doing to improve the infrastructure? So I'll definitely be going over that in future slides. So stay tuned. So next slide. And so starting off with the power distribution network. Next slide. So there's quite a bit of, this is a really busy slide, as you guys could see. So what is an electrical power distribution network? There's certainly a lot of math involved, but definitely this is not something that you guys should be worried about. I just show this slide for fun, just to really show what it does take to kind of understand a lot of the electrical engineering and power engineering that goes into the development, design, and implementation, of these systems at the contractor level, right? If you guys are ever curious about this stuff, I'm more than happy to nerd out and talk about it at another time. So next slide. So now translating that into English, what is an electrical power distribution network? Simple definition, it's a network of electrical components used to supply, transfer, and consume electric power. And so here in the United States, we have several common distribution voltage levels. And the keyword is distribution, right? Not sub-transmission or transmission, which gets into another story. And I'll talk a little bit about it in the next few slides. But here at UC Riverside, we really deal with, two voltage levels really at the distribution point, which is 12,000 volts, which is the 12 kV that you see there highlighted in red, and also 4,000 volts, or the 4.16 kV. And the 4,000 volt systems are usually associated with our older, infrastructure and older buildings that we still have on campus and are working actively to replace to 12 kV. On the right-hand side, you'll see a picture of a building, a very simplistic picture that really shows some of the sections of an electrical system within the building. So you have, your branch circuits, your panels, circuit breaker panels, transformers that transform the voltage, let's say from 12 kV or 4 kV down to, the 480s, 277s, 120s, 240s. A lot of those voltages that I just named are, used commonly, obviously, with the common equipment that we use in everyday life, right? Such as laptops, computers, research equipment, etc. Next slide. And so how do we actually receive power here on campus? So our main point of connection between the city and the campus is something called our electrical substation, which I'll be going in depth a little more in the next slides. But again, this is the main point of connection that we have, with the city and the campus, and it's considered very critical infrastructure. Additionally, there's a lot of switches and cables, that go from that point of connection all the way downstream throughout the campus. And so this carries our electrical power to the campus buildings, through, again, a network of many cables. And our building infrastructure, supporting distribution at the building level, and it can vary based on age and the condition, such as the electrical panels, all the switch gear in the electrical rooms, and again, switches and cables. And backup generators. So we definitely have a lot of standby generators throughout campus, which again, I will review in future slides. But something to keep in mind with the generators is that they really do only provide power primarily to support life safety type of circuits within a building, and not necessarily carry the entire load of the building. Next slide. So now getting into our infrastructure within the campus. Next slide. So this picture right here is our electrical substation. So it's really located across the 60 freeway. And a lot of you may or may not notice it when you're driving along this freeway, but they're right next to the solar farm panels that you probably most likely see, and adjacent to the parking lot 30. So like I mentioned before, this is a point of connection between the city of Riverside and our campus. Next slide. So just some cool snapshots of the substation, kind of looking west inside the substation. So you'll see the switch yard and a lot of pieces of equipment, a lot of infrastructure that supports the cables that are coming into the campus and then to the campus. So that funny looking apparatus right there that you see on the right side is a high voltage circuit breaker. So what this does is really protect the system from any serious anomalies that may occur from the primary side, coming from the city to the secondary side, going to campus. And the bottom picture right there is a picture of our substation switchgear, which is the interior of the control room within our electrical substation. And I'll be talking a little bit more about this as we move along in the presentation. Next slide. And so there's quite a bit on this picture or slide, but don't worry, I'll walk you guys through it. This is just a very high-level overview of our electrical substation. And on the left side, that picture shows some of the cables coming from the city into our substation, which are shown in the diagram below. And it's those two green parallel lines, or sets of 3 lines going into the substation. So the way it's configured is we have 69,000 volts, and in a power system, that's considered a sub-transmission line coming into the substation and then being transformed via a transformer down to a 12,000 volt system for us to, feed into our buildings. There is a little bit of redundancy built in to this setup that we have shown right here, between the city and the substation. So for example, if one of these sets of lines goes down, we're actually still able to power the campus at an adequate level, depending on the time of year, of course. Whether it's hotter or cooler weather, that definitely plays a factor in the power demand for the campus. And again, if one of these lines do go down, the campus will certainly feel some sort of blip, a momentary blip, within the system, which we've actually experienced before. An important point to note here is that there are actually other substations within the city of Riverside that feed our campus. And some of those are a few miles away, anywhere from 3 to 6 miles. So there's a lot of coordination when something does occur with the city of Riverside on seeing what the actual issue or problem, may have been, essentially the root cause. So one last thing to point out right here is that we do have joint ownership of this critical asset with the city of Riverside. So we own a certain percentage of the substation, which is highlighted in blue. Next slide. And a few more schematics for you guys. Hopefully you guys are enjoying this. This just essentially shows the cables from the point of connection at the substation down to our campus power distribution network. So there's a set of cables, A side and B side that we really split, that feeds the entire campus. And I'll get a little more into this, like I mentioned, later, but that's all this is showing, just the power diagram of our electrical substation feeding down to campus and into our buildings. Next slide. And so now getting into the fun stuff, the disruptions and power outages. Next slide. So a very busy slide, but I'll walk you guys through it. So before I get into some of the common causes of disruptions and outages, there is some terminology that should be explained as we go along in this presentation. So some common power quality terms in power engineering is something called a system fault, right? All this is really just a short circuit within a power distribution system. And there are many types of short circuits or system faults that can occur and affect us at different levels and different scales, either throughout campus or at the point of connection, or even at the city of Riverside, within the city of Riverside. Figure 1 on the bottom left shows the different types of faults. And again, this is very technical, so don't worry too much about it. But there are certain types of system faults that are a little more common than others. And there are some that are more severe than others. So if you look at letter A and letter B, those are the most types of common types of system faults within a power distribution network. And all that is one of the phases within the lines gets associated with a grounding wire, right? And so a good way to maybe imagine this is like a tree branch kind of hitting a power pole. And this will certainly cause some sort of disruption within a localized area of a power network. And now getting into some of the definitions. So we have something called a momentary interruption, temporary interruption, and sustained interruptions. These all vary based on time. And you'll see all you need to focus on within that long definition, technical definition, is just the underlined portion, which highlights the 30 cycles to 3 seconds for momentary. So when we do have some sort of disruption, it could be classified within just a few seconds, right? Anything below 3 seconds. Then you have the temporary interruption, which is anywhere from 3 seconds to about a minute. And then a sustained interruption, which is about a minute and beyond. So these are more prolonged types of periods of outages that we may attribute to certain faults within a system. And then getting into the dip or sag, this is really just a voltage sag or a voltage dip in the voltage that is incoming, let's say, to a building or to a greater power system. And all what this really is just, again, a variation and a certain percentage of that waveform, voltage waveform, that gets varied, right? Anywhere from 10% to 90% of the actual waveform getting varied. And this lasts anywhere from a few milliseconds down to a minute. And there's a good representation on figure 2 in the bottom middle picture that shows an example of a 20 millisecond dip or voltage variation. And then the last one that is certainly very common that we may see in buildings is voltage flickering. So you could really just attribute this to a flicker in some sort of lighting system or light bulb. If you see something kind of dim very fast, or you notice something and you think you're kind of going a little crazy, it's probably really happening, right? It could be very sensitive to the human eye, and again, just flickering of the lamps. And a good waveform of this, just, it's very similar to a system dip in some ways, but it's just more random variations in the voltage that is coming into the building. So all of these things can be caused by some sort of certain disruptions of the power system, whether it's at the city level, substation level, or within our internal power distribution level. The last figure 3, is just a representation of a momentary interruption, which again is anywhere from 30 cycles to 3 seconds. This one, for example, is showing a little bit more than that, which is 60 milliseconds of a momentary interruption. So this could cause, wreak havoc on very sensitive electronic equipment within research buildings and rooms. Next slide. And so some common causes of disruptions in outages that we do experience. Like I mentioned before, we could see this at the city level. So there's definitely a lot of coordination that we do with the city of Riverside and outreach that we do with them on, some of the initiatives that they're currently taking on within the city. What are they doing with their aging infrastructure? If they do some sort of maintenance, 3 miles away from us, will that affect us? Or if they do some maintenance within our substation that is not our equipment, how will that affect us? We could certainly see outages and disruptions when there's power line damage. Let's say a car hits some sort of distribution pole near campus. That's certainly a possibility. Power supply shortages, I threw that in there, but that's something that hasn't really occurred, but pretty close. As you guys may be familiar with the CalISO flex alerts that we recently experienced, that's a good example of power system demand that we need to be wary of at the city level. So again, our facilities group does a lot of coordination with the city, especially during heat waves. And then going down to our campus infrastructure, I actually threw some pictures down on the bottom right corner of the slide. You'll see old switchgear that we currently have at our central plant, and the picture right next to it is a picture of a vault that holds a SF6 switch. And so there's a lot of projects and efforts that we're currently undertaking, between our group and planning, design, and construction to really change these out and really build a more robust infrastructure. But these are just a few examples out of many that we do currently have on campus, unfortunately, just based on the age of the campus. And it's everything from switches, switchgear, circuit breaker panels, even transformers. And we run into situations where we do notice, loose connections and terminations within these pieces of gear or equipment, where that could be a potential for a system fault or a short circuit. Weather events, really big one, like I just mentioned. Everything from rain, flooding, and lightning strikes. The thing about rain, it's a very tricky one, because if you do build enough moisture within a certain piece of equipment, that could actually create some sort of path for electrical current to flow through, right? The same thing with winds and gusts. If enough dust builds up, let's say on some sort of insulators or circuit breakers within the substation, that could cause a pathway for a current to flow and cause a catastrophic system fault. So whenever extreme weather events do happen, our facilities group is certainly out there, making sure that everything is okay, with the resources that we definitely have. Heat waves, CalISO again, flex alerts. So one of the weaknesses for any electrical system or equipment or even your phone is thermal heat, right? Thermal stress on the electronics or cables or switches. We definitely make sure that our equipment is cooled adequately, as adequately as possible. And there's a lot of projects out there, for example, at our substation, to definitely cool a lot of that equipment, to help keep it running appropriately. We definitely want to avoid situations where components overheat, the thermal stress is reached, and a failure or disruption occurs. Circuit breakers could trip and cause a certain feeder down the line from the substation point of connection to basically shut off, right, to protect the system. So again, heat is something that we do want to avoid, especially during summer months, which is inevitable, but again, keeping it as cool as possible is key here. Next slide. And so what are some of the responses and processes that we have in place when it comes to facility services and the communication portion? It really does depend on the scale of power disruption that may occur. And this does determine the scale of communication. Our priority is definitely campus research and safety for our staff, students and faculty. Our staff in particular are out there, working on this equipment and trying to get it back up and running. So we need to make sure that everything is being followed appropriately, and they have the proper equipment and tools to do their job. And we just want to, have a safe environment for everyone, for the public safety. So we provide a notification to building occupants via email, and this could be, if it's building specific, if there's an issue at the building level, we send a notification to those impacted buildings, set of buildings or building. If it's a more campus-wide event that we experience, we work with the university communications, and we definitely update as we understand what the issue may be. And our maintenance crew is out there, doing their best to determine estimated repair times, what it's truly going to take to get everything back up and running and everything back in tip-top shape. When events occur, whether it's localized or a greater campus event, we still communicate with Riverside Public Utilities to make sure that if the root cause was caused within their systems, and if they captured anything from their devices to help come and give us some sort of root cause. There's a lot of working together that we do with the city officials and our account manager. Like I mentioned before, our facilities maintenance crew would be assessing the issue, seeing the extent of the damage and the true impact to campus. And sometimes this does take time, just because they have to be very thorough and go to several locations to really find the problem or issue at hand. So, with all the resources and tools required, it can take some time, unfortunately, to get this, adequate and accurate information to the greater campus community. But rest assured that they are working very hard to make this happen. Another point I want to mention here is our central utility plan, which could easily be a whole nother presentation in itself. But they're very important players when it comes to outages and disruptions on campus. If the central utility plant, faces some sort of issue, typically we'll see other issues, cascading within the other utilities, right? With our chilled water system, the heating and cooling systems, our compressed air systems, and even our vacuum pump systems. So a lot of coordination going on within a lot of groups when outages do occur on campus. Next slide. And so what about building generators? So there's quite a few of them throughout campus. I'd say about 40 of them, on standby, as standby systems. And there's definitely plans to, improve the testing and preventive maintenance, which I'll get to right now. But true or false, and then you guys see the answer there already, but, building generators are designed to pick up the entire load during a power outage or emergency situation. This is false. It's typically only rated for emergency circuits or life safety type of systems, which really is just a fraction of any building load. And of course, there's certain runtimes associated with, these generators. And there's fueling considerations that also go into the generators when an actual disruption or power outage does occur on campus. So now going into the preventive maintenance, what are PMs? It's essentially maintenance that is routinely performed on, these physical electrical assets to reduce the chances of equipment failure and unplanned events. So I highlighted generator testing and automatic transfer switch testing in particular. This is a very important initiative that we'll definitely be improving on starting in January of 2023. And essentially right here, we'll be doing regular scheduled tests. And I believe around the December timeframe of this year, we'll be choosing certain buildings to do generator/ATS testing, as kind of like a pilot program to begin the actual PM. But there will be about a 1 second outage during these tests, so something to be aware about, but more to come on that. And our facility services group will definitely be reaching out to the greater campus community and building stakeholders to be aware of this testing that is upcoming. But just some more PMs that are going on right now. They occur with our motor control centers, which are essentially our switchgear, our transformers, and doing some gas analysis, which essentially tells us the state of the transformer and seeing if there's moisture buildup within the transformer itself, and also circuit breakers within the buildings. And the picture down below actually is a good example of a generator circuit or ATS circuit. So those are emergency loads that are associated with our MRB building. So that's a newer system that we currently have right now. Next slide. And this slide just shows, just a list of some of the generators that we do have on campus. So quite a bit of them. Next slide. So when it comes to power disruptions, how can we build resilience, right, for the building stakeholders? What can the building stakeholders do to, help mitigate or reduce, damage to the equipment? One of the easier items is, UPSs or surge protectors. UPSs are interruptible power supplies that are usually connected to critical equipment, such as servers. Servers are a very good example that usually have UPSs connected to them. And they provide surge protection. On top of that, they provide power conditioning, which really does regulate the incoming voltage, like on a normal day, right? You really want to make sure that the voltage signals that are being fed to your sensitive equipment are within the nominal range, acceptable nominal ranges. On top of that, they provide battery backup to the equipment. So this really does depend on the power rating of your equipment, whatever that may be, and the specified UPS. It could range anywhere from, about a minute or 2 minutes of runtime to about, several minutes to about an hour or two. And really the purpose for UPSs is, number one, to protect your equipment, but to also give you enough time to, shut down your equipment and unplug it in a safe manner without, damaging really anything. Another easy, mitigation measure for power disruptions, or when they do occur, is surge protectors. So, simply put, they just protect against damage to electronic equipment from voltage variation spikes. Another easy item that can be done during, to help mitigate these events or damage to equipment is simply shutting off equipment when it's not in use, turning it off and unplugging devices. Now, I realize this could be difficult in some cases, depending on the type of equipment, location, the type of research that may be going on, and even, staffing and resources, right, that may be available at that moment in time. But, for extended periods of time, during holidays or, you'll be on vacation, unplugging certain pieces of equipment like your computer may be a good idea. Also looking at the current electrical outlets that you have within a room, right? Making sure that you're not overloading anything. And if you're unsure of, this part, feel free to reach out to facilities to, help make sure that everything is, appropriate and plugged in, correctly. And if, in some cases there may or may not be enough outlets within a certain room, that's certainly something that we could, help and take a look at. And also simply emergency readiness planning, with your own building managers, building stakeholders, and really for anyone who oversees, certain research, having a contingency plan in the case of a outage or disruption, and having those active conversations amongst, one another to see what can be done to help mitigate, damage to sensitive equipment. The important thing to remember when it comes to, outages and disruptions is the main problem really with any power outage is the restoration of power, right? So when everything gets turned back on, you see an influx of, current draw. Everything wants to grab that current all at the same time. And so that causes a voltage dip or a voltage variation, which further causes, more amperage to be drawn within certain branch circuits within a building. So, going back to the point of shutting off equipment and unplugging it could be very important, during certain times of the year to make sure that, sensitive equipment and electronics do not get damaged. Next slide. So now getting into the fun stuff, some of the campus electrical distribution projects that several groups have been working on. So next slide. So before I get into that, there are 3 R's that I like to follow when it comes to any type of, I guess, utility system, but in particular, electrical distribution projects and maintenance. It's the 3 R's, redundancy, reliability, and resiliency. All of these things combined are, create a great recipe for a stable grid, modernized electrical system, and really an efficient type of operation when it comes to our electrical infrastructure overall. When it comes to redundancy, we certainly want to make sure that we have, adequate amount of cables and, switching available to basically keep the power on, right? So if you have a certain cable and that one goes out, do we have another cable that is running in parallel that'll keep the system running? And so a lot of our projects do incorporate this component, which is very important. Reliability, of course, right? So when it comes to reliability, you may be asking, well, is this certain piece of equipment going to remain on if, something occurs? How reliable is it? What's the age of it? Does it operate adequately? Does it operate appropriately based on certain conditions? Again, very important component when it comes to electrical distribution projects. And the last one of my favorites, is resiliency. So a very easy way to think about resiliency is essentially the strength of a electrical system, right? How strong is it, and how much is it able to withstand when it comes to abnormal events or extraordinary events that are, not typical or just very rare, right? And how fast is it able to recover and get back to normal state? Again, putting all these together really creates a stable electrical grid at the end of the day. Next slide. And so this slide really just shows some of the high-level projects that we've completed thus far. Again, between our facilities group and our planning, design, and construction group and our contractors that we deal with on a regular basis. The first one that I have highlighted there as a bullet point is electrical studies and arc flash assessment. So all this one did was look at, our entire distribution system, right? And do a lot of, single line calculations and make sure that everything was documented, up to date, looking at short circuit and energy incident levels, short circuit potentials at certain locations of campus. So this project really did highlight other projects that have been completed and are still ongoing, to this day. A very cool project that was completed was our underground high voltage cables, and so there's a picture on the bottom right that shows what was completed, what section of cables were replaced and upgraded to higher rated cables. And this essentially brought it up to a 25% increase in ampacity. Very important, again, for campus growth and resiliency at the end of the day. And this goes back to the component of thermal stress. So now when we do have heat events, this section of the electrical grid is able to handle that much more, when it comes to thermal ratings and thermal stress. Additionally, there's certainly more expansion, cable projects that are going on, especially with new construction projects. So whenever we have a new construction in design or being planned out, we see what the localized area looks like in terms of our infrastructure. And again, not just electricity, but it goes to all of our other utilities. But in doing so, we've been able to replace close to 5 miles of cables, and again, upgraded to 500 MCM to 750 MCM, which is just a rating of the cables. And currently in construction, right now, there's another 300 feet that is anticipated, and in design for another 15,000 feet. So quite a bit that we're doing around the campus loop internally. Another very good project that is currently underway, or that we've completed and still ongoing, is the replacement of SF6 switches. So if you take a look at the top right picture right there, you'll see those green boxes. Those are actually 4-way electrical switches that are pan mounted and above ground. So this is very good for many reasons. If we take them out of the vault and put newer technology above ground, it just makes it easier for our maintenance crews to be able to operate these things when needed, and provide the switchability that is required in many cases. Additionally, going away from the SF6 technology, which is a greenhouse gas, this is very good for our environment, obviously, and we want to go away from several decades old technology, and make sure that we have a much more reliable switch for our campus. Additionally, transformer removals of PCB, a lot of toxic and hazardous material from older transformers, and also upgrading our 5 kV system to our 12 kV system, a much more efficient and modernized distribution network. So quite a bit has been completed thus far. And again, our central utility plant, making sure that they're taken care of and their electrical infrastructure surroundings are at adequate levels. They do have a lot of aging infrastructure within the plant that does go out sometimes, and everything from the motors and pumps, just inadequate operation that does occur from time to time. So there's planned projects for that area as well. And then the last one, smart metering efforts. So this really does provide, us facilities and maintenance groups the real-time information to make, appropriate and accurate decisions at a moment's notice. So it's an ongoing effort between several groups right now. Next slide. And so in total, I kind of put a reference put of 2019, but there's been a lot of many electrical projects that have, moved forward and been completed, but thus far, this amounts to about $10 million in just construction costs. So the amount is actually higher, but we've, allocated about this much money thus far in a lot of these projects that I just highlighted. So there's definitely more to come, and it's a very exciting time for our campus and improvements in our infrastructure. Next slide. And so what do all these projects support overall? There's many key points that that should be highlighted when it comes to the initiatives that have been completed for our electrical distribution system. The number one thing in my mind here is safety and a reduction and elimination of electrical hazards. Again, by replacing a lot of this old switch gear or switches or cables, we do create a much safer environment for our maintenance personnel and for the greater campus community overall. It definitely supports future electrification efforts and sustainability initiatives. So think of things like decarbonization, electrification, renewable systems, and future renewable systems that we may be looking into, such as battery storage. Right, we need to have a robust and strong electrical grid within the campus to be able to support that backfeeding that will be required. And again, that goes into our electrical vehicle charging stations that we do have, within certain parking lots as well. They support expansion and growth of the campus. So as we add more buildings and as we electrify more systems in general, there's going to be more power demand required for the entire campus community. And of course, minimizing disruptions and outages. That's a big one, and I think it's one of the more important ones for this entire presentation. But again, reliable grid, you create a more stable grid. Load balancing and power quality, it certainly improves those aspects. And load balancing is a very important initiative for our electrical maintenance crew whenever they require to do switching between load banks at the substation point of connections. We need to make sure that everything is operating adequately and reliably, and we're able to switch loads with minimal disruptions for the campus community. And like I mentioned many times before, grid stability and just modernizing our infrastructure. So our infrastructure really is a lot of things, right? Not just our electrical infrastructure, but it's obviously the buildings, our water systems, natural gas, steam, anything and everything. This just touches on electrical in this particular case, but one improvement here definitely takes us a long way. And the last point is smart metering and digitalization of our utilities. So we want to be able to control and visualize our utility systems in a more futuristic and modernized approach, right? So getting that real-time and historical information to do deep analysis and make informed decision at a moment's notice is definitely key within all these projects. So we make sure that we include that component and support that component overall. So next slide. All right, guys, so we're slowly reaching the end of the presentation, but this next part is future electrical substation maintenance that we're planning for. So let's jump to the next slide. So we're working with Riverside Public Utilities as of right now to develop a robust plan, and also our maintenance crews to do maintenance at our main point of connection. And this is a substation that I spoke about many times and that I showed pretty extensively at the beginning of the presentation, but it's essentially doing a lot of cleaning and maintenance for the interior switchgear located in our control rooms. And so there's a good picture right there, the bottom right. So it's really a lot of the internals that we'll be looking at. And there's a lot of old wiring that hasn't really been replaced since the inception of this critical asset. And I think it goes back to the 1950s, 1960s. So it's very important that we push this type of maintenance forward and coordinate with the city. And so we'll be doing this sometime in 2023, most likely at the end of the year of 2023 when it's cooler weather and there's less load on campus. But this type of work will take approximately 2 weeks to complete. And we'll be doing switching, a lot of switching within the campus, but mainly the point of connection at the substation. and switching our loads, from one bank to another. And so that was that earlier diagram that I showed that showed those arrows pointing down to, to campus, which were the circuits at this level. So again, it's going to be a major effort, but we will work, with major campus stakeholders and building managers to make sure that everything, goes as smoothly as possible. So we have about a year of planning for this major event, but this will be very important, and it'll definitely, increase resiliency, reliability, and even redundancy at that level for the entire campus community. So I think that's it, guys. Next slide. Any questions? I think that was quite a bit to take in. So luckily this webinar will be recorded, and you guys can certainly watch it again if you guys have any further questions, but I think there may be a few questions. Alejandro, can you help me read some of these?
Yes, there are 2 questions from earlier in the presentation. The first one is, are there backups in place for the older buildings on campus?
For the older buildings. So I think we'd have to take a look back at that list. Are there any particular buildings that this person may be thinking about?
As of right now, it's just a general question of older buildings on campus. I believe they're talking about the generators.
Yeah.
Okay. Particularly Watkins.
Watkins. So let me take a look and jump back at some of these. So Watkins, so I think that's something I'd have to maybe pick at, but I believe in the basement of Watkins, there is a generator that is associated with that, location. I'd have to take a look at the rating in particular, and I could maybe answer this question specifically outside of the presentation, but I believe that there is a generator associated with Watkins, at least in the basement area.
Okay. Our second question is, are there plans to put emergency backup generators at either LSP or Spieth Hall for the vivarium?
That's a question I think that may be better suited for our electrical maintenance in particular. I don't know of any plans as of right now, but that's something that we could certainly take a note of and consider if it's not currently in the plans. We definitely want to, create a more robust, emergency, system in place for, the older buildings and critical research. But that's something we could definitely take a look at and get back to you guys on. So I'm writing these notes down as we go.
Okay, another question just came in. Is there a timeline to incorporate more solar panels or sustainable energy sources for buildings on campus?
Yeah, so as you guys may know, we recently completed 3 solar rooftop projects, located within the West Lothian building, our student rec center south side, and our student services building. So those were just completed, I want to say last year, and they were commissioned appropriately at the end of the year, around there, after summer. So that definitely added a good amount of, KW solar generation to the campus. As of right now, besides new construction that is going on, I don't believe there's any plans or set timelines in place. But there's certainly more to the story when it comes to just, putting in solar. We look at the rooftops, the condition of the rooftops of certain buildings. So unfortunately, there is a bottleneck when it comes to certain other infrastructure that may support future solar. So as of right now, there isn't anything concrete in place, but it's something that we're always looking at, and even looking externally outside of the university, seeing if there's any, local fields that may exist where, we could maybe, get some sort of PPA agreement, to help our renewable portfolio. But it's something we're always looking at. And in particular, my group, we're always, taking a look at a lot of the parking lots that still do not have solar in place. So those may be good candidates, for future projects. Definitely costly, since they would require, support systems versus, rooftop systems. Definitely a difference in price. but that's something that we're always supporting, and we definitely need in our long-range development plans. And again, just to reemphasize, for new construction buildings, that's something that we request for new buildings. Any other questions?
As of now, no. If we want to give it a little more time for any other questions.
Yeah, and guys, if there's any other questions that you guys may think of outside of the presentation, feel free to contact us. We're more than happy to take them in and get back to you guys. Yeah, I think I'm taking a look at the Q&A. I think that's it for now. Okay. Well, if there isn't any other questions, I want to thank you guys for attending this presentation. There's 2 more times for tomorrow. So if you missed a part of it, you can certainly join the other presentations scheduled for tomorrow at 12 and 3 p.m. But again, thank you guys, and this concludes the presentation.